So, our lecture today is on functions in pseudocode. They're two separate ideas. As I was saying, functions we can do without pseudocode, pseudocode we can do without functions, but today we're going to look at them together. So with the idea of functions, my point of view here is it's a way of, it's repeatable code. We take a little bit of code that seems to work in a general case, and we make a function out of it, and then we can just call it whenever we want. The other beautiful thing about functions is if you get them nicely done, you can make that repeatable code available to the outside world. And we'll talk about that through this idea of libraries and APIs. Pseudocode, you can program your whole life without using pseudocode, I think. But pseudocode does allow you to sort of write code. It's called pseudocode. Pseudocode meaning like, but not exactly. But the idea is that your pseudocode could then be implemented in any different programming language. So it's agnostic in terms of, and I use that word agnostic, meaning it doesn't really care. It doesn't have any firm sort of idea on how you're going to implement it. So you could turn pseudocode that you'd written over to somebody who likes to write programs in C, or somebody who likes to write programs in Python or in Java, and then they would implement it using the syntax of the programming language of their choice. And the pseudocode would work for everybody. Basically, what the pseudocode is going to say is, your code will kind of look a little bit like this. Of course, it'll be different because you'll implement the rules of your language, but this is what it will do. And yeah, pseudocode's nice for that. So these ideas, I hope, are not new to you at all. And this will show up in your quiz later on this week. We have the programming sort of constructs of sequencing, conditions, or conditional was part of our selection, and then loops. And I don't guess I need to say too much about that. Let's introduce, as part of that, an idea of functions. So you may have seen something like this before in your life. Functions represented in mathematics. So the function x, where x is, when we take x and square it and add 1 to it. I mean, you could substitute x for all kinds of values. So imagine you substituted the number 0 for x, then the value returned would be 1, because 0 squared plus 1 is 1. If you substituted the number 1 for x, the value returned would be 2. Now, what if you put a negative number in there? Then you get strange results, right? -5 squared is actually 25, because when you square a negative, you get a positive number, right? So that's kind of strange. Also, if you put a decimal number, 0.05, if you square that, you get a half of a half is 0.25. 1.25. Anyways, I'm not here to give you a math lesson, but you could see some different results. You could even see more different results if you substituted various numbers in for x and y in this function g. So the function g takes as parameters x and y. X is then added to 2 times y plus 2x. Now, so for example, if both x and y were 0, then you just get the number 2. Now, if x was a 1 and y was 0, then you'd get what? 1 plus 2, because this would turn into 0. Anyways, as I said, I'm not going to do all that math with you. That's what we have computers for, right? But if we sort of understand the math, that makes it a little bit easier. Now, the idea of functions represented here, we also use a term for them called subroutine. I think you could say that it's kind of a part of the idea of software engineering. In software engineering, the idea is to bring up the standards of writing programs so that we have programs that can go from one place to another and people can use them and understand them easily. So part of software engineering is the idea of repeatable or reusable code. Reusable code. So in other words, I write a little bit of program that has a general purpose, and then somebody else can use it. And so from software engineering, we do sort of, I see a link into these idea of libraries, where people have written nice little bits of code that we can use. because it's general purpose. And then it improves our programming quite a bit. So what's going to happen in a function is a function is going to take some inputs, which we'll call parameters, and it's going to process those inputs and output something. In a flowchart, you've seen a rectangular structure for a process. When we have a function, what it means with this particular rectangular structure, do you see the lines going down there? A couple of parallel lines on either side. Well, that means that this is a function. And so the function, z takes the value here of the function of whatever is returned from the function when x and y are input. The function would then have to be declared and explained somewhere else. So that's what we do. We take a little bit of code, we declare it, we explain it, and then all we have to do is input a couple of variables and we get a resulting output. So all of the processing is actually happening inside inside the function, but we would understand what that function does. So for example, today we'll look at a function to make the average of 3 numbers. And so we would input as our x, y, and z 3 numbers and output the average. And so all we would see on a flow chart would be a box like this saying average 3 numbers. We would know that we put in 3 numbers and we get out the average. Then somewhere else we'll declare how that actually happens. And so here's a flow chart for that type of thing. We're inputting 3 numbers for an assignment, for a quiz and a test. We add those numbers together. We get the overall, which is an average. So we take the total of those and we divide by 3, and that's our output. Now we could do that step by step, but we might notice, hey, you know, that's kind of an average. Maybe we could make a function to do that. So what I'm talking about is taking these 2 processes here, the sum and the overall, put them aside as a routine that can be repeated, which we'll call a function, and then explain it separately. So that's what we've done. We've replaced those 2 processes with this function process, which just says input these 3 values, assignment, quiz, and test, and output the overall. Then what this means is somewhere else we have to describe what's happening in that function. So over here, we're describing what happens in that function. Well, what happens in that function is we input these 3 variables. You see, when I say input these 3 variables, we see the in the declaration of the function, we put a brackets, and then inside there we've got three identifiers, which are 3 variables. And then those 3 variables then are processed inside the function, and something else is produced, the average, and then the average is returned, so that we can say that in this function, we input these 3 variables and we output the overall. Now notice, I want you to notice something here. Here what we've done is we've said average grade, and we put assignment, quiz, and test, because here those are variables that we have. But here, when we declared the function, we didn't say assignment, grade, and test. We said x, y, z, because we want this to be a general purpose function. We want to be able to put in any x, y, z we want. We could just put the numbers 10, 5, and 6, and it would work. But we could also, any numbers that are of the same type as this x, y, and z can be used when we call that function. So here we're actually calling the function, and we're giving it as inputs assignment, quiz, and test. On another example, we might give it birth, age as one number, IQ as another number, and foot size as another number, right? As long as it was numbers. All right, you see what I'm saying? So this will work with any numbers. It just happens that we want to use assignment, quiz, and test that we're with. So this is what I mean by general purpose, right? Although all we're saying about this function is it takes 3 numbers and gives you the average. That's what we've abstracted it to say X, Y, Z. Just take 3 numbers and give the average. But here we have a specific implementation where we're saying, well, what we actually want to take the 3 numbers of is assignment, a quiz grade, and a test grade. Okay, so when we declare a function, we will Okay, so I have to be careful what I say here, because in not every case will you have inputs in a function. 99% of the time you would. I mean, you could, I suppose, have a function without inputs. And not in every case would you have an output from a function, right? Maybe a function just does something, right? But in most cases, we have inputs, and you can have multiple inputs, x, y, z, x, multiples. But in Python, for example, we only have one output. So at the end of the function, we have a return statement. When I said we only have one output, the output is the thing that is returned. So you have a return statement at the end of the function. You may return a value or not. Usually we do. Now this is the other thing. When we get to the point in a function where we return, what that means is exactly what it says. We return to the main program. And I want to show you something here. It's kind of quite important. In the memory of our, so imagine this is the memory. In the memory of our computer, what we do is we have this concept of a stack. The idea of a stack is we put things into it, all right, and then we bring things out of it. So the way a stack works is the last in, the first out, LIFO. We put things in, and we can build the stack up, and then when we're ready, we take them out. Now that's what happens when we call a function in a computer program. And I'm looking for my eraser. When we call a function in our computer program, we will put into memory the details of that function and any variables that we're passing. When the function process is complete, then that goes out of the memory. All right, so we put it in when we call the function, and we take it out when we're finished. And so that means that when the function is complete, as far as the computer memory is concerned, any vestige of that function is gone, right? The function kind of disappears at the end when we do the return. So we return a variable and the function's gone. It's no longer in the memory. That's kind of an efficient use of the memory, I suppose, but it's worth keeping in mind that that's what's happening. So what it means is the variables, all the variables that we use inside that function, all their values are gone, right? When we get out of the function, the variables were part of that function. They were in memory while we were using the function. As soon as we do the return, all that stuff is gone. And so the only thing that's back in the memory is if we return that variable to somewhere else, it might be sitting in the memory there. But the actual function, the processes that went with it, the variables that were used in the function, that's all gone as soon as we get to return. Does that make sense? So bearing in mind the computer memory is where this stuff is being stored. And that's what this means, this last line at the bottom of this slide, which says, when the function ends, the flow returns to the main program. The memory of that function is gone. We're back here in the main program, and we're just continuing on. Now, we probably have a returned value from that function, and that's what we can sort of take forward. So functions can have input variables. And so I hope you saw there in the previous slide where the function was to calculate the average. The input variables there were X, Y, and Z. And then, yeah, they, as it says here, they only exist inside the function. When we call the function into memory, we put those variables in the memory. So our X, Y, and Z are there in the memory stack. And as they might get changed or whatever during that process. And then when we finish, out they go, gone. So they're very temporary. Anything that's happening inside the function is temporary because the stack has to be unloaded so that we can go back to the main program, right? So in the program, I should have labeled this, I suppose. We're sailing along in our main program. We call the function ends up in the memory. We're working with that. When we're finished, we get out, we return from the function, we go back to the main program, but the function is gone. Does that make sense? Anyways, what we're supposed to do here is we're supposed to trace the execution of the previous program when quiz is assigned the value of 80, assignment is assigned the value of 90, and test is assigned the value of 73. Okay, so tracing. We would need to see the program. You know what I think I'll do is let's look at this program. It's There it is. All right. So there's the program. I think do you bear with me? We'll try and do this in Python. We got enough time, right? So I don't know if I've got idle on here. I think that we tried this last week. Yeah, we do have it. It's been installed since then. Maybe it was a different room. Maybe it was 131 that I didn't have idle. Yeah. Okay. So what we're going to do is we're going to do this is the program, which probably should wear my glasses so I can see what I'm typing. This is this program. What does it do? It does a grades average. So we actually have a function which is going to take 3 grades. This is how we do a function in Python. We have to say what it is. I'm just going to call it A3 because average of 3 grades. It's going to take in the values X, Y, and Z, just like we said. And what it's going to do with them is it's going to take well, that's so easy. All right, it's just going to take a value called average, and average is going to be equal to X plus Y plus Z divided by 3. That's it. And then we're just going to return average. So we need to have our program. Now here, the way it works in Python is so I'm going to number all of these things, right? So this is line number 1. This is line number 2. And this is line number 3. And now I'm going to the main. And I'm numbering them as they appear in the program, right? So this is going to be line number 4. Let's make this 4. So what's going to happen in the main is that we're going to have, what were the numbers? It was the quiz, the lab, and the what was it? Quiz, lab, and test, right? So quiz takes the value of an integer input, and we just say, what's the quiz value? I'm going to, okay, so then test does the same. I'm too slow in typing, so I'm just going to copy and paste. So that's going to be test. And then the last one was lab, right? And lab takes that value. So again, I'm just going to copy and paste and just do lab. So we input those 3 values, and then we get the average, which I'll just call AVG. And what that is it's the return value from the function. So here I'm calling the function. Okay, so this is line 4. This is line 5. And this is line 6. And the average is going to be, what I'm now going to do, you'll see I'm in the main program. I'm in the main program. I'm going to call the value of the function. So I'm going to call a function. When I say A3, that's the name of the function. Now look, I'm going to feed into it some inputs. What are the inputs I'm going to feed into it? I'm going to feed into the inputs quiz, test, and lab. These are variables that I've just declared above there. And I've got and so this is line 7. And the reason why I'm showing you this is because I want you to see how a function works. Okay, and then we can go and look at it on the flow chart, etc. But I think if we see it in a program, it'll kind of make more sense to us. So now if I print it out, so much easier to type when I'm wearing my glasses. It's amazing. I can actually see the keys. All right, so which is, kind of amazing. I mean, I can see them, but all right. So what I'm actually going to do here is I'm going to put a print statement in here. So I'm going to say, what is the line number? So this is line number 2, and now it's called average. So I'm going to print it there. Yeah. And then here I'm going to print. This is another print statement. I'm going to print all three of these. So what line am I at? Let's say I'm at line 6. So I'm going to print the, yeah, actually, I'm just going to put, I'm too lazy. Okay. What the heck? Quiz, test, and lab. So they're going to be in that order. Let's just put them quiz. If I don't put a space between them, will they be jumbled up? I bet they will, but let's see. Test and lab. I might have to come back and put spaces between those, but we'll try it like that for now. And then here we're going to print the average with the number. Oh, well, we got that, right? So I don't need to do that because it's already done here. Number 7. So I want to run this and I want you to look at it and see if you sort of get the idea of how a function works. So this is grades function. So the quiz, let's just take a number. This person's doing pretty good. They got a quiz of 90, 89, a test of that, and a lab of what, 90, 95, because labs are so easy, right? And so notice the first print statement that I got was at line 6. Let's have a look. Why is that? Wouldn't you think that we would start printing here? The program doesn't start here. The program starts here. And you notice that because the first thing it does is ask me for the quiz number, then it asks for the test number. Do you see that? This is really important that you get this. The program starts here. It doesn't, the function is only processed when we call it. Here's where the function is being called. There's no function running until I get to line 7. Does that make sense? So at line 6, we still don't have an average yet. We don't get the average until we go to this line here. Line 7, we get the average. We should print out the average twice. Let's go back and look at the output. So yeah. Oh, what happened here? Well, that's interesting. That's not printed those. My print statement is not working the way I expected it to. Let's go back. That's weird. I do it with just one. Oh. And this one. That's the weirdest thing ever. I might have to abandon this and try and figure out what happened to my print statement. My apologies. Okay, so now the average is working. It didn't like it when I put the three things together. All right, so the average, so we got the average printed twice. The first time it printed the average was on line 2. The second time it printed the average was on line 7. But look at the way the program was processed. First, it went to this line, line 4. So I should say, let's just do this again. This is line 4. This is line 5. This is line 6. So we can see what's happening as we go now. Yeah. This is just weird, but my apologies for this. So we're going to do the test. Line 6, we've got all of these things going, and we've got the lab. Okay, so that was So you can use one variable, but you can't use multiple variables in the same print statement. How about that? Well, not unless you can, but not unless you put a space between them. So let's do that again. Quiz is 89, test is 90, and the lab is 80. Okay, so we start with line 4. We look over here. Line 4 is where? Line 4 is here. We don't do any, we start in the main program. You can see that, right? Start in line 4. This is the start of the program. Then we go to line 5, right? Which gets the test value. Then we go to line 6, which gets that. Now we see that because this is where we're printing 4, 5, 6. It's there, right? Line 4, line 5, line 6. Then we print out these things. These are the 3 things here we're printing. I'm saying I'm printing after line. I should say after line 6 there, right? But we print those values. So we've got those values in memory. Then what's the next line that we print? Line 2. Why line 2? Because what happened here is when we did the average, we called this function. The function A3 is now being run. And we go here and we print average. Now, here I'm printing average. Here I'm printing AVG. So why? Inside this function, there is a variable called average. It doesn't exist anywhere else. It only exists for lines 2 and 3, right? After that, it's gone. And here, and this one exists after line 7. So when we print them out, we get that difference. Where's that? Where's that output? Come on. So I hope you can see that there, right? So the program sort of moves around a bit. I mean, it processes through the main, starting there and goes down to the end. But in doing so, at one point, it calls the function, which has been declared up here. And so it has a little bit of a sidetrack into the function at line 2. And then when it's done that, it goes back and does this. Now, that relates to our memory thing, right? It's working through the main. And so I wanted you to notice these different variables as well, right? So we see that we've got average here, turns out to be average here because we returned the average. When we return the average, what happens is it comes out of this function and AVG takes it. This is a different place in the memory, but it's holding the same value because we returned that value to it. Does that make sense? All right, so I mean that's enough of how you say that's my version of tracing that for now. We'll go and have a look at tracing it a bit more. So why do we use functions? As I mentioned, my view on that is it's probably something to do with sort of software engineering. The idea of software engineering, we use that term because it's applying the discipline of engineering to software. And when software first started, it was kind of artistic almost, right? And it's still a little bit artistic. I mean, people apply their own sort of ideas to it. But the idea of software engineering is to standardize it. And so if we can standardize it, for example, we'll standardize in the way that we do our coding. We get different programming languages, but we can have a bunch of standardized functions, libraries that everybody can use. And as it mentions here, we can relate directly back to our concepts of computational thinking. In computational thinking, we had 4 basic sort of things that everything's rested on, right? The 4 fundamentals. So one is decomposition, breaking things into smaller tasks. Well, functions will work with that, right? So we got a big task, we break it down into smaller tasks, each of which are functions. Pattern recognition. Pattern recognition is about, we notice that something seems to keep showing up. And so that would be a good target for making a function. I mean, so we keep having to do this. So maybe we could write a function to do it so we can call the function and do that repeating. The abstraction, the idea there, how that relates to functions is we get a general case. We generalize it down to the simplest, like we did with the math. We don't care about, well, like we did this with this problem, it became X, Y, and Z, just 3 numbers. You know, in the end, we don't care if it's a quiz, a lab, or a test. What we care is it's 3 numbers. And as I said, it could be, you know, 3 temperatures on 3 different days. All right, it's just we're taking 3 numbers and we're averaging them. And yeah, as it says there. And then the idea about code readability when you start writing programs, you'll soon find that you can end up with pages and pages of programming things. So one of the things we try and do is try and keep individual functions down to like a page of code so that it's readable, so we can see it all and keep it in our mind at one point, so we can, you know, find the errors and fix them. And so by breaking the problem down, that's decomposition again, but also by making our functions at a reasonable size so that we can read them, we do solve that problem on the readability and the maintainability. So that's also a thing in software engineering, right? We want systems that are easy to write, easy to read, easy to maintain. The best way to do that is to break things into modules with functions. All right, so the function has a couple of different parts to it. As it says there, it has a header, and in the header we have the name of the function, we have its inputs, and we have the result. The result is going to be the returned value. So if I went back to, I escape from there and go back to our Python, this is how we do a function in Python. DEF, I guess, is short for define, because we have to define the function. And so we've defined this function, and I said the name of the function is A3. The inputs are X, Y, and Z. And then we do something with X, Y, and Z, and then we return a value, right? Which is some computation of X, Y, and Z. So, yeah, so that was the header. The header was the bit that said, you know, the DEF in Python. Actually, I don't know. Let's go back to Python. I like Python. Let's go back to Python. Look at it. We also use that here, right? Here, we use the name of the function and inputs. But notice this is different than X, Y, Z, right? We didn't have to say X, Y, Z. I could have put the number 456 instead of quiz test lab. It will accept it. It's no problem. But because all that this does is take three numbers and get the average. And we don't care what three numbers it is. But in our case, we're taking these three numbers and doing that with it. Anyways, I'm repeating myself, so I'm going to stop. So we created a function. I just called it A3 because I didn't like typing a lot, but it was the average grade. And it had three inputs. Doesn't matter what the three inputs are. They need to be the right type, you know, integers. But other than that. So that brings us to this concept of an API. An API forms an interface. The I there stands for interface, application programming interface. So the idea there is that somebody has written this code, which is available for other people to use. How do other people sort of take advantage of their code? Well, through the API. So the API is going to be like functions that are published and available for everybody to use. And so that we call that a library. And so the idea there is, instead of you having to write your own code that might do some difficult thing, which a lot of people are doing, some other software engineering people have actually gone and written that code for you, and they've stored that as in an API library. So here's an example of that. So maybe you want to do some stuff with Twitter. Maybe you want to find out, you know, some statistical results from a particular tweet. You can use the API, which is available with Twitter, to get that information and then process it how you like. So Twitter has made an API so that people can get statistics based on what's happening with it. Right, so I told you that this lesson has two parts. The first part was about functions, which now seems to be complete, or well, as complete as it's going to be in this lecture. The second part is about pseudocode, and that's where the rest of this will be. Now, as it says here, there's three different ways that we represent algorithms. Algorithms are represented in flowcharts, which you're sort of familiar with. We can just use English, and then we've got this other idea, which is pseudocode, which, as I mentioned to you before, some people have referred to it as structured English. Now, the thing about pseudocode is that there's not just one way of doing it, all right? So there may be different ways of doing it. However, in this course, it would be good, as it says here, if we all did it the way that you're going to see in the next couple of slides. Does that make sense? So just so that we can sort of standardize in this course. So you could do it slightly differently and it wouldn't be wrong. You might see me do it slightly differently sometimes, in which case you should tell me, well, that's not the way that the notes are. And that's just natural. You know, people will have their own flavor of pseudocode. Now, when I mark your papers and stuff like that, I'll try and be sort of, how you say, generous about that. But yeah, just bearing in mind that there's more than one way to do it, but this is what we're going to see today is the way that we're going to try and do it. Just as it says to avoid confusion. So we've got the way we're going to do it. So let's say this is CNIQ version of pseudocode for this semester, which may change next semester, right? Okay, but this is how we're going to do it. So if we have a function, we're going to use, what do they call this? Upper camel case. So that means the first letter of the function is capitalized and any other name after any other word that's added to it is capitalized, right? Any variables we'll use in the normal way that we do in a computer program, for example, which is just camel case. So the first letter is not capitalized, but if there's a second word, then it will be capitalized. Constants, that's exactly how we described it when we had the, sorry about that, when we had the lecture where we talked about variables and functions. Sorry, variables and constants. All right, so the other thing about it, and this is where you have to sort of watch me carefully and maybe tell me, you know, to watch out, Mark, you're not doing it the way we do. Because if you use Python, we don't have to declare what type of variable it is when we create the variable. In other programming languages like Java, for example, C, you do. You can't just create a variable. You have to say what is the type of the variable. That's what's happening here. So when we define the variable, for example, here is defining a variable called my age, and we're saying this is an integer variable. If you were doing Python, you would just assign an integer number to it, and then it would be an integer variable. So we don't actually do this in Python, so be careful with that. But we can cast them in Python, and you saw me do that when I did the inputs and I put the int around it. That's turning it into an integer. Strings, that's another type, and yeah. So what here's creating a function, and we're actually specifying that these variables that are going to be the inputs, what is the type? So we do that for in the pseudocode for declaring the variable and also for declaring the function. We say what is the types of the variables. Quite important in many programming languages. We don't have to do it in Python, so we might get lazy, but you should do it in your pseudocode. All right, so functions need to have a keyword. We can use the keyword function. Now, notice that's different than Python too, right? In Python, I didn't say function, I said def, right? Now, if you're in a different programming language, you might use the word function. You know, each programming language has its own syntax. In Python, we say def. Here we say, for pseudocode, function, and everybody will know that that's a function. And if you're a Python programmer, when you go to code this, you'll say def. And if you're a Java programmer or some other programmer, you'll do it a different way. And so then there's the name of the function, and then we've got our inputs. Now we use these curly braces, and that's kind of coincidental too, I suppose. If you're programming in Java or you're programming in C, every time you have a programming structure, you open it up and close it with curly braces. So that's kind of nice, and because that's the way it is in a lot of programming languages. We don't have braces in C. Sorry, we do in C, of course. We don't have braces in curly braces in Python, and that's because we use indenting. So if you're programming in a language like Java or C, the indenting doesn't matter. You can indent it however you like, but you can put all your program on one line if you like, but the curly braces must be there. With Python, you can't do that. Python, each line has to be separate, and your indenting is very important. You don't get your indenting right in Python, your program won't work. So here we indent it just for readability. But and so that's important in pseudocode. In a different programming language, it might not be. Now, notice what's happening here. So what's happening here is we've declared two integers are going to be the inputs. X and Y are going to come in. Then we're declaring a new integer value called S, and it's going to take its value from adding the inputs. And then a new value A, which is, yeah, so this would work with our average. This is the average of two numbers. Okay, so how do we represent selection? If, notice the brace here, it's not a curly brace, a round brace. This is for the condition of the if statement. So this means that if this condition is true, then we do this stuff, which is inside the first curly brace. And then we do an else for the false, right? So for the true, we do the then, and for the false, we do the else. All right. So that's how we do it in many programming languages. And that's how we do it in pseudocode. So this is pseudocode we're looking at. With while, again, we have the condition is in a round brace, and then we have a do. So while condition do, then we open up our curly braces. What's happening inside the curly braces is everything, as long as this condition is true, these things that are inside the curly braces will be repeated. That's different than Python, right? In Python, we don't use do. We just say while and we put a colon there. And then we do indents instead of doing the curly braces. In Python, we use the colon and the indents. Just so that you're aware that pseudocode's not the same as Python, right? It's not the same as Java. But some programmer looking at the pseudocode could go ahead and write Python or Java from it. I'd say it's actually more like Java than it is like Python. All right, so and I think I've mentioned this to you before also, the equal sign, it doesn't mean equal. It means takes the value of, that's the way I use it whenever I see it. So this variable takes the value of something. But you could look at it when we're testing for equality, or here it says checking for equality, we use two equals. So what's on the other side of the two equals, that would be in a condition. We would say X equal Y. That could be a condition which would be either true or not. So that's a Boolean expression with the equal. And it's either true or it's false, right? X equal Y, true or false. These other symbols can be used for our Boolean tests as well. So the exclamation mark means not. So we put that in front of an equal, that means not equal. Look at this, greater than, equal to, greater than, less than. That means not equal to too. There's two different ways of saying not equal. Of course, that means less, and this means less than or equal to, and that means greater than or equal to. Must be like that. We put the equal afterwards. We don't say equal to, greater than, like you do in math. All right. So be careful with that with your programming. Oh, well, finished that. That's cool. So we finished the lecture. We could, yeah, let's have a, how much time we got? That was 49 minutes. The recording hasn't stopped. So let's have a quick look at the tutorial so you can see what's going on there. So we got tutorial and a lab this week. If you look at the tutorial, it should be familiar to you because it's about what we've just been talking about, right? I think average grade. So this is here, right? So in the slides, we have flow charts for algorithms for average grade and overall grade. And so the average grade takes three inputs, adds them together, divides them. This is not Python, is it? This is how we would do it in pseudocode, right? Now the overall grade was the name of the program. So the program, can you see right here? At this point here in this line, that's where we called the function. That's equivalent to this line here. So if I was going to look at the pseudocode, this would be, this thing here is the overall grade. And this thing here is the average grade. So this is what it looks like in Python. This is what it looks like in pseudocode. So in pseudocode, we say function, then we name it, then we get our inputs, and we have to say what is the type. Now, if you look at that, how that's in working in Python. Again, it's pretty much the same, isn't it? I mean, I hope that you can see that it would be easy to go from that to this. I hope you can see that, right? All we're doing is just using some different words. So in our pseudocode, we say function. In our Python, we say def. Right? And then, so I didn't say average grade, I just went A3. Right? But then the other stuff is the same, right? We created, oh, well, this has got one more step. This one created a total first, right? So it got S as a total. S stands for sum, I suppose. I mean, if I was going to make this the same, I'd have to put in another line of code, which would say, you know, sum takes a value of X plus Y plus Z. And then the average would be equal to the sum divided by 3. Now it's the same, right? Oh, problem here. Sum is a reserved word. I can see it's a reserved word because it turned purple. So I'll just call it S like they did, right? So don't want to be using reserved words for my variables because I could get some bad results. All right, so that would work the same. Now I've got an extra line of code. That's the only problem. But so we've taken this pseudocode and we've made our program look the same. As I said, if this was in Java, it would be a little bit different. But have a look here. Now we've actually called this a function. I've called it the main, but okay. The main function is called overall grade. And what does it do? It gets the 3 variables, same thing. Only difference with the pseudocode one is we had to declare what kind of variable they were each. And then we calculated the average. And here we had to say that the average, well, overall, they called it overall. I called it AVG. Anyways, I hope that kind of makes sense for you. Now, what you have to do, yeah, I've kind of done this by, you saw that I did this. I did my easier way of doing a tracing by just running the program and putting lots of print statements in it. But so let's try that. Let's run it. Now they've got the numbers 80, 85, and 89. So let's run it and see. Now what I should do is, yeah, let's just run it and see. So with the numbers 80, 80, 80, 85, and 89. Okay, run. 80, 85, 89. And so, yeah, so what happens? First, at line 4, we get the 80 going in. Then at line 8, we get the 85 going in. Then at line 9, we get the 89 going in. All right, so all those values stay the same. They don't change. Then at line 10, we calculate the average. That's happening here on line 2. Then, boom, there it is printed out. So same kind of idea. Now, your exercise for the tutorial is you're supposed to, and we did this, we've done a tracing of this, have we not? Didn't we do this last week? No, we did. So your job is to what? Write pseudocode, but this time, yeah, we've done it. So, I mean, what's this all about? Anyway, so it looks like we've already done that. I guess the idea is that we're supposed to convert it to a function. So it would be slightly different if we converted it to a function. And so let me show you what I mean. So it's something that we've kind of done, but we're going to kind of do it just a little bit different. So let's have a look. This one I'll have to write on the board, I guess. Right. The area of circle can be computed by area takes in the value. Okay, so I could have the circumference. Okay, so we could have 2 different functions. We could have the function called circumference. Now you could give it as an input a radius, and I guess that's an integer value. And then as a float value, you could give pi, or and look, I'm going to open a curly brace there. Or you could maybe for pi you could use math, and you could just use the math value of pi. And so how you do that? Oh well, that's a program. So let's just put this in. We're going to input the value of pi, and we're going to input the value of the radius. And then we're going to create a thing called circumference, or C, or call it whatever you want. Let's just call it C. C takes the value of what's the circumference? 2 pi r, right? 2 times pi times radius. Now you can do this a lot quicker, actually. You could do this with only one line of code. You just say, this is the lazy man's way of doing it. You just say return 2 pi radius. And so what that'll do is it'll take 2, it'll take pi, it'll take radius, and return it as a value. It kind of seems kind of shorthand, but why not? Eh? Why we want to put extra steps in? I mean, part of being a programmer, I think, is not that's it. That's our program. It's one line of code, right? So you might ask, well, why do you bother, right? So then in your main program somewhere, you'd have a thing which would be you'd have an integer, and we'd call it radius, and we'd give it a value. Maybe we'd ask them to input it or something. Yeah, so some input. How do they do that in their flowchart thing? Not flowchart, in their pseudocode. For inputs. Pseudocode conventions. Yeah, it doesn't. About inputs. You know what? We're not given instructions for it. So I'm just going to say the integer of the input of the radius is going to be an input. And yeah, so I'm just going to say that. And then we're going to have a float, because this is a constant, pi. And so constants are like that, right? And so we'll say that's equal to 3.14. That's enough. So that's what we'd do in the main. And then we'd say, okay, circumference is equal to, so we call this function circumference and then we put in our values, which are radius and pi. Okay, so this is all you'd need for the pseudocode. What I want to do, just having fun, because I like to do this. How are we doing? We got a bit more time, right? It's 11 o'clock. Let's do that in Python. Why not, eh? Mark likes Python. Can you tell that? So this is going to be our circle program. And so we're going to have a function there, which is called circumference. And circumference is going to take two values, which is going to be the radius and pi. I'll just do R and P. And it's pretty simple, this one, right? I mean, now with Python, I need to put a colon. And so I'm just going to say return because I'm lazy. Return what? 2 times pi. Where are my glasses? 2 times pi times r. That's it. Very, very simple. Then in the main, I'm going to have this. So I'm going to get that value. So what do I want? Radius. Radius takes the value of an integer input. And the integer input is going to say, what is the radius? And then when we want to print out the radius, we can also shorthand that. We can just say print whatever is the circumference. So I'm just going to say circumference, because this is just a string. And what I'm going to put here is I'm actually going to print from the function. So here's the function name. And I'm going to put in the value of the radius and the pi. Now, the problem with this is that I haven't actually declared pi yet, so I better do that. So pi, I should do it as a constant, right? Okay, so bit of fun with Python programming. Here I'm calling, this is where I call the function, right? Now you would expect me to say circumference is equal to circumference, but instead of doing that, I'm just going to print it. See if it'll work. Might be surprised. So I'll call this circle. So ask me for the radius. And it prints out the circumference is 18.8. Now, the thing is that I could now create another function here. I could say, okay, so what I want is I don't just want the radius, I want the, what was the other one? The area, right? I want the area. And so you might remember what the area is. So I'll do that with I did R and P, so just to show I don't have to do the same one, I could do RA and PI, right? So just to show that they don't have to be the same. I could have done R and P again, but I don't want you to think that they have to be the same. And so this time I'm just going to return again, because it's only a single it's only a single calculation, right? So why we're going to write a bunch of stuff? So I'm going to return pi r squared, right? Pi times r times r. So easy. And then I'm just going to print out what is the area. And so I'm just going to print out. Now notice, I got to make sure that I got the spelling the same here as here, right? So what this is going to do is it's going to call a function called area. It's going to feed into it radius and pi, and then it's going to, and then whatever is the result of that, the returned value will be printed. So the radius is, that was 3 last time, it's 6 this time. Oh, got an error. Doesn't like 3 times return. Oh, because there's no R. It's a raw. Run to the end. Happens a lot. I mean, you know, you're always going to make mistakes. You should never write programs in front of people in a classroom, right? You're always going to make mistakes. But so you get the idea very, very quickly. Now I just got these little functions. They were so easy, right? And that's why you find them in libraries everywhere. You can do this exactly right. I mean, now, if I wanted to make it even better, I mean, I suppose I would include math library. I think now it's not working, is it? Should come up with a, let's do this later. All right, so I'm going to say I'm done now. You guys can stay and watch me figure out the include math, because I haven't done that for a while, because that's not working. Or you can go, it's up to you. I'm going to find out how to do the include math. Right? Python. Let's use a different Python math. Come on. Math library is where I want. So how do we do it? Okay, so we got math.py, I think. I thought it was math.py. No, method. Constant there, math.py. Yeah, all right. So how do we include it? Not very helpful in this. Random module. Python as including. Import. It's import, not include. Now, as soon as I say import, the reason why it wasn't working for me, I could tell it wasn't working. Just another hint for you, right? I tried to do include, and I could see that the color didn't change. So I know that it's not right. All right, so knew that wasn't right. I wasn't going to go down that thing. It's actually import. So import math. Good. And then here, instead of saying pi is equal to 3.14, what we're going to do is we're going to say pi is equal to math.pi. And so we'll get a much better representation of the number. The number will be more exact. Okay, I think that'll work now. So we got our import. Yeah. Let's put it in the main. So, okay, let's run. See. I don't know, actually, I don't know. Maybe it does need to be at the top. Well, program hasn't died yet. Yeah, so now we're getting it's working, and it's working a little bit more. So I'm sorry I came without remembering the import thing. Okay. Anyway, so there we go. It does kind of work. That was kind of fun. What am I showing you on here? We've got two different functions. The functions, in this case, I'm actually calling the functions inside a print statement. You can do that. I mean, you know, if you want to save yourself time. And we see the returned value is what happens with the function. Enough. Okay, class. Make sure you sign the sign-in sheet. Unless there's some questions. Any questions? No, all right.